Hopefully you had a chance to try this practice question. If not, pause the video, give it a try before you continue, okay? So it asks us to sketch this function and then evaluate the given function values. Now, this is something called a piecewise function, and I know some of us are like, I haven't seen this in a while, or I don't remember ever seeing this. Piecewise functions just means that your function is going to look different on different intervals. So here we have two intervals, x is less than 1, and x is greater or equal to 1. You could have more of them. Some piecewise functions will have 3 pieces, 4 pieces, 5 pieces, and so on. But this guy only has 2 pieces. So let's try to sketch this out. I have my x-axis, and I have my y, or my f at x-axis. I know there's going to be 2 pieces to this function. One piece is going to be where x is to the left of 1, because it's less than 1. One piece is going to be where x is greater or equal to 1, meaning to the right of 1. So let's take a look at to the left of 1. What kind of graph is that? Well, that's your y equals mx plus b, so it's going to be a straight line. So when x is 1, let's see what happens. If I put in x equals 1, I'm going to get 3 times 1, which is 3, minus 2, which is 1. So when x gets really close to 1 here, I'm going to get the value of 1, and then it's going to be a line that it has a positive 3 slope and a y-intercept of negative 2. So I'm going to get a line somewhat like this. Okay, so it extends forever and goes down to the left forever. Now, at the point x equals 1, it's not exactly 1, it's actually a hole right there, because when x equals 1, we actually jump to the next piece. Okay, so let's take a look at what this next piece is, which I will do in green. This guy is a quadratic, so it's going to be a parabola. It's going to be opening up because it's positive 1 as the a coefficient. My vertex is going to be negative 1 and 2. Okay, so the vertex is going to be to the left of 1, which isn't going to be in part of our graph, because we only care about this part of the graph when x is greater or equal to 1. So let's think about what happens when x equals 1, because this is included in this interval. So when x equals 1, I'm going to get a 1 plus 1, which is 2. 2 squared is 4. 4 plus 2 is 6. So when x equals 1, I'm going to get the value of 6. And then it's a parabola, so it's going to go up, 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 up forever. Give or take. Not drawn to scale, but those are the 2 pieces. On one side, to the left of 1, it's a straight line. To the right of 1, it's a parabola. Okay? All right. Now we want to evaluate each of these. So part A, we want to evaluate f at 0. So how do we do this? Well, 0, which interval does this belong to? Interval 1 or interval 2? 0 is definitely less than 1, so it's going to belong to interval 1. Meaning f of 0, we're going to use the first piece. So it's going to be 3x minus 2, but instead of an x, I'm going to put in a 0. So 3 times 0 is 0, minus 2 is negative 2. So that means that f of 0, or f at 0, is negative 2. Okay, continuing on, part B, f of 1. Which interval does that belong to? Let me just clean this up so we can see this more clearly. F at 1, meaning x equals 1, belongs to the second interval, because the second interval is when x is greater or equal to 1. So I'm going to use my parabola instead. So this is x plus 1 squared, which is 1 plus 1 squared, plus 2. 1 plus 1 is 2, 2 squared is 4, 4 plus 2 is 6. So f of 1, or f at 1, is 6, which we see in our graph. Okay, last part, f at 2. So which interval does 2 belong to? Well, 2 is definitely greater than 1, so it belongs to interval 2, meaning we're going to use the parabola equation again. So x plus 1, which is now 2 plus 1 squared, plus 2. Okay, let's do some number crunching. 2 plus 1 is 3. 3 squared is 9. 9 plus 2 is 11. So f at 2 is 11. So we just found these 3 function values.